Chapter 6 Buffer Overflow Attacks.
The unauthorized reproduction in whole or in part of this publication in any form is prohibited.
We will now copy the required files from the enclosed disk to the hard disk.
Here is our first example program. It shows the content of the int a variable, which is visible in the program code. Let's compile it. As we can see, after transferring the second argument of the call, the int a variable has been overwritten with the value 0x41 corresponding to the letter A. To discover how the overwriting of the int a variable was possible, we will now look at the program examples using GDB. As we can see in the case of the car buff 10 variable, the stack has been increased to 24 bytes, 0x18 in the hexadecimal system. In the case of the int a variable, the stack has been increased to 8 bytes. By transferring 32 A characters, 24 plus 8, to our first program, we have overwritten the value of the int a variable.
The next task will be to overwrite the int OK variable, which controls access to secure resources. After transferring the long character chain, it was possible to crack the program. But how can we do this if the variable controlling access does not exist? Let's test our next example program. We will now use a GDB to find out what happens at the moment a program call parameter that is too long is transferred. As we can see, the program wanted to jump to the address 0x41414141, which does not belong to its memory area. Let's now try to tell the program to jump to the correct address, which will allow it to skip to the procedure of login and password verification. This will be the address 0x080484C7.
The address of the jump has to be written in reverse order, starting from the last byte.
As we can see, everything went as expected. We managed to fool the application. Now we will analyze another example to exploit using the shellcode. In this case, a ready address that we could transfer does not exist. We will need to create our own shellcode and add it to our program. Unfortunately, a shellcode containing indirect closing function calls is not appropriate. It is necessary to create a code containing system function calls. We will obtain a ready-made shellcode from the binary program image using a objdump tool. The final version of our shellcode looks like this. We will therefore use a ready-made exploit that takes advantage of the techniques we learned while reading this chapter. As we can see, the operation has been successful. We gained access to the shell.